Hello to you all good people. Here's another lesson. Today, my intention is to go over derivative rules of trigonometric functions. And then between the 6 rules that we have, I'd like to go ahead and prove 2 of the rules that are harder. One is the number 3 rules, the derivative of tan x equal to secant square x. And the next one is the derivative of cotangent x. Okay, so I'm going to go ahead and prove that using the first 2 derivative rules of sine and cosine, and those are our basic derivative functions that we're going to use. And to find the proof of those are more of a original proof that you have to use the limit definition of derivative and set it up, and that's very easy as well. But for the purpose of this lesson, I like to go ahead and prove the other 2 harder derivative rules, and we are using not only the derivative of sine and cosine formula, but also we have to use the quotient rule. Okay, that's what we're going to do. Okay, let's get into it. So the first thing we need to do, we need to rewrite the tan x as a quotient of sine over cosine, and let's do that. So this is d dx of sine of x over cos of x. Okay, that's tan of x. That's one of the identities that we have to remember. All right, now that we have this, we have to go ahead and use the quotient rule. All right, so quotient rule says the top, you have to take the derivative of the numerator, which is sine x, the derivative of that, that's cos x times cos x, that means the denominator. All right, and then minus the you leave the numerator alone, which is sine of x, but then this time you have to multiply it by the derivative of the denominator, and then derivative of cos x is right here, negative sine of x. Okay, and all of that over cos x squared. All right, so now that we have this, let's go ahead and simplify. That's cos squared x when you multiply cos x and cos x, minus and minus, that becomes plus, that is sine squared x all over cos squared x. Remember, cos x all squared is the same as cos squared x. So this expression and this, they're both the same. All right, and final answer is that cos squared x plus sine squared, that's Pythagorean identity. That's the very basic one, the foundational identity. That was the Pythagorean identity. That is equal to 1. Okay, that is 1 over cos squared x, and 1 over cos squared x. Remember, 1 over cos is secant, so this would be secant squared x. All right, so that is the proof of the derivative of tan of x being secant squared x. Fantastic. Now let's move on to the next question. We're going to do the same thing. We're going to change the cotangent of x as a quotient, so that becomes cos x over sine x this time, because it's a reciprocal of a tan x, but the cotangent of x is. So now we're going to go ahead and use the quotient rule again. So here it is. We have the first, we have to take the derivative of the top. Derivative of cos x is negative sine x times sine x, which is the denominator, minus, you leave the top alone, that's cos x, and then derivative of sine x, which is the denominator, that becomes cos of x. All of that over sine x squared. Very good. Let's simplify. That is minus sine squared x minus cos squared x all over sine squared x. Very good. Now, let's take out -1. We're going to factor -1 out of the top, the numerator term. That is sine of squared x plus cos squared x all over sine squared x. Now, we know that sine squared x. We know that sine squared x, this is Pythagorean identity again. So that is 1. And we have a negative here. So the answer, the final answer on that one will be 1 over sine squared x. And there's a negative in front because there's that negative right there. Okay? And then the last step is 1 over sine squared x is cosecant squared x, and there's a negative and you put a negative in front, and then that would be the final answer, and it would just proved that the cotangent of x, the derivative of cotangent of x, equals to negative cosecant squared x. All right, these are the two proofs that we have done. Basically, they're part of the trigonometric functions derivative rules. Out of the 6, we used number 3 and number 6, but you can actually go ahead and prove number 4 and 5 as well. They're very easy. The same concept applies as long as you change everything to sine and cosine, and then you go through the product rule or the quotient rule easily. All right, if you found this useful, subscribe, hit the like button, comment in the comment section below, and let me know what else, what other topics or lessons you want me to go over. And until next time, for my next videos.